All right. So section 1-4 talks about combinations of functions. So we're going to look at the sum, the difference, or product, and the quotients of various different functions. And so parts of this you're going to find really simple. I'm hoping that that's going to unfuzz. Apparently it's not. Is that better? Better, better. Worse, better. There we go. All right, so here is the sum of two functions. So you're going to, if you see this following notation, f plus g of x, they're asking you to take the function of x and add it to the function of g. If you see this notation, f minus g of x, subtract the two functions. If they're being multiplied, multiply the two functions together. If they're being divided, divide the two functions, bearing in mind that the g function cannot have a value of 0. Why? It's in the denominator. So let's look at some examples here. So you're given the f and the g, and then we have to, hopefully this part will be simple for you. We have to add them together, right? So my f function is 3x squared plus 2x minus 4. I'm going to add to that my g function of 4x squared plus 8. Would you collect like terms, please? Is this an equation? No, you're just collecting like terms. So collect like terms. Is that what you got? You're like, please let them all be like that, right? All right, so for your note purposes, you might want to say that there's your f of x and there's your g of x. So how is f plus g of 2 different? This means the sum of the two, say that again? Right, because remember that's your x, right? So remember this notation over here means f plus g of x. So aren't these one and the same? So that means that f plus g of 2 is using this function and just replacing it with 2. So Dakota is right. I'm going to take my already simplified function and input 2 into it. So then follow order of operations. Do you think there's a difference between f minus g and g minus f? Yeah, because there is a difference between 3 minus 2 and 2 minus 3. So make sure when you do the difference of two functions that you use substitution parentheses. So I'm going to take f first, which is 3x squared plus 2x minus 4, and subtract from that the g function all in parentheses. Why would I do that? Yeah, you need to distribute that negative because you're subtracting the whole function, not just the 4x squared. So I've got 3x squared plus 2x minus 4 minus 4x squared, but a minus 8. Now collect like terms. Do you agree with mine? Okay. So now you do g minus f of x on your own. You done? About? Is that what you got? So the difference between them is difference in signs, right? I can't promise you that it will always be that way. We'd have to do a few more to make a conjecture, right? All right, so flip the page. So that part was easy. If only, right? Now we're going to multiply and divide. We're going to take the two functions and we're going to multiply them together. So same kind of process. We're going to take f of x, which is x squared, and we're going to multiply that to g of x, which is x minus 3. So here's my f of x, and here's my g of x. When we have a binomial, don't we distribute? So we're going to multiply the x squared to each of those. So what do I get? Minus 3x squared. Yep, that's it. Now, part 2, just like we did in the last one, isn't f of x times g of x the same as f times g of x? And this time they're saying plug in a 2. So plug in a 2 into here. Use substitution parentheses and follow order of operations. What do you get? -4 is correct. Now, division. Division can get a little dicey. All right. So we're going to take f, which is x squared plus 2x cubed, and divide it by g, which is x squared. There's two ways you could do this. What do these have in common? X squared. You could either, here's way 1, you could either factor out that x squared, and what are you left with here? What's x squared divided by itself? 1. And then divide this by an x squared, don't you get a 2x? All over x squared. What happens to the x squareds? They cancel. Or, way 2, you could take and divide each of these by x squared. X squared over x squared plus 2x cubed over x squared. What happens here? It cancels out and becomes 1, and then this cancels with 2 of those. So no matter which way you go, don't you get 1 plus 2x? Either way, for this particular one is acceptable. What can x not equal? 0. X cannot be 0 because this is a restriction. So if x were 0 here, the denominator would be 0. All right, then do number 2. Now you switch it around. Put g up top and x squared plus 2x cubed on the bottom. Can you do it both ways for this one? No. You have to factor with this one because there's only one term in the numerator. Everything cancels in the numerator. What do you have in the numerator? 1 over 1 plus 2x. What would be the restrictions on the domain? If you set this not equal to 0, so if I have 1 plus 2x not equal to 0 and solve for x, I get 2x is not equal to -1, x is not equal to -1/2. So this is a domain restriction. How do I write that in interval notation? Oh, but wait a minute. What's right here? Go back to Algebra 1, 2. It doesn't matter that I canceled that out. What would make that not 0? Yeah, because if x were 0, wouldn't it also make the denominator 0? Mm-hmm. So x cannot equal 0 also. So now, how would I write my domain in interval notation? These are my critical values, -1/2 and 0. So how do you show to the left of negative 1/2? Negative infinity. And then do I include negative 1/2? Nope. So negative 1/2, parentheses. And then union, right? And then start at negative 1/2 and go to 0. Both of those are parentheses because we don't want to include them. Union. And then how do you go to the right of 0? 0, positive infinity. So none of those had brackets, right? So go back to this one. How are we going to show the domain restrictions on this one? Because before we canceled, that was our thing. So x cannot equal 0, right? So how do you show that domain? How do you show to the left of 0? Negative infinity to 0. Union. Then what? 0 to positive infinity. Good. All right, so that's easy, right? Except for maybe your domain restrictions might be somewhat challenging for some of you. Then we're going to go to what's the definition of the composite of two functions. So look at this down here. You remember Fogg and Goff? Fogg and Goff? G-O-F? No?
Not at all. I was never taught Fogg and Goff.
Yes, you were. Go talk to Nelson.
The name is familiar.
The name is familiar.
Familiar.
Okay, so some Nelson people are saying yes and some are no. She's gonna be mad at some of you people. All right, I know she taught it. All right. Well, this is true. Okay, all this means, this is, you're going to take and look at the notation here. If f comes first, you're going to take the f function and put the g function in for every x of the f function. Whatever the g function is, that's what gets placed into the x of the f function. So it's like putting one thing inside of another. If the g comes first, you're putting the f function inside each of the x values of the g. This is very similar to that difference quotient, right? All right, so this one says the domain of Fogg is a set of all x in the domain. In other words, you ought to be able to use any x that you want to. Now that's granted that there's no denominators, but we're not going to give that to you. All right, so look what happens here for this first example. So you're given that f of x is x squared and g of x is x plus 1. We're going to find f of g of x. So we're going to take the f function, which is right here, big parentheses, okay? So there's only x squared, right? We're going to take the value of the g function and replace it into that f function, the x of that f function. So do you see why I'm putting an x plus 1 squared here? The f function is something squared. The g function is x plus 1. That's the thing that's being squared, is the g. So now we can figure this out. So this is f of g of x. There's your proper notation. And then if I were you, I would write it out, unless you're able to do it in your head, and then FOIL it. Yes. And so you do get x squared plus 2x plus 1. That is your f of g of x. So now that I have my f of g of x, they want you to find g of f of x. Oh wait, we haven't found this one yet, have we?
No.
So let's find f of g of 2. What do I do with that?
Put the 2 in the g.
Yeah, well put the 2, well you could do it up here. And actually that actually might be easier for this one, wouldn't it? You could put it up to here, you could put it down here, couldn't you? Either one will work. To me that looks simpler to plug into, doesn't it? So it just depends on what's easier. For this one, I'm going to plug into the original one and put a 2 right there. What's 2 plus 1? Squared? 9. So doesn't it equal 9? Would it have mattered if we'd done that down here? What's 3, what am I plugging in? 2? What's 2 squared? 4. What's 2 times 2? 4. What's 4 plus 4? 8. Plus 1? 1. 9. Still equaled 9, didn't it? Either way, you're going to get the same answer. Now, you find golf. G of f of x. So you want g of f of x. So take your g function and plug the f in for every x. And I would use substitution parentheses wherever I see an x. That one was actually a little easier, wasn't it? That one they're not asking us to plug into anything. All right, so you're gonna mess around with that a little bit. Can I take that away? All ready? Okay. All right, so let's look at example 4. We're going to break composite functions into their simpler functions. So, if this is h of x, this might blow some of your mind. So if this was h of x, we have to go backwards. All right, so you just came up with the composite functions, right? Now they're giving you the composite function. They want you to come up with the two separate functions that created it. So look what happened here. 1 over something squared. Think of it that way. Take whatever's in the parentheses and think of it as something. So we want to find fog, f of g of x. Wouldn't the main function be 1 over something squared? Can you see how I might have plugged in down here in x minus 2? Do you see how x minus 2 could have been the g function? That was plugged into the general f function of 1 over something squared. Yes or no? And how did I figure that out? Look at what's, I can't change the 1, right? But that I could easily replace with an x squared. That's why we have 1 over x squared. What is it that I'm covering up? X minus 2 has to be the other function. And because this is inside the parentheses, it must be the g function. What is surrounding it? The f function, 1 over something squared. Look at the next one. Look at what's in parentheses, covered up. Couldn't the main function be, they actually say 4. I think this is a boo-boo, this should be a 1. Or that should be a 4, vice versa. But isn't it 1 over something cubed plus 1? Right? What is being cubed? X minus 4. Couldn't that have been subbed in there? So the g function is x minus 4. And then the x for the f function would be this cubed, so x cubed. So I've written in here, whatever is in parentheses can be your g of x going backwards. So that's where you start. Look at what's in the parentheses. So let's look at, and you have a couple of problems today where you're going to kind of fiddle around with that. See how you do at it. So now look at example 5. We've had some trouble finding domains. Didn't we just talk about it with example 1? Okay. So you're going to find the domain of a composite function when the original functions are restricted. So if this is f of x, is this restricted at all? Is there any restriction on that? Is it in a denominator? No. Is it under a radical? No. This is not restricted then. That's why, do you see the domain is from negative infinity to positive infinity? That's an unrestricted domain. Look at the g of x. Is that restricted? Yes. What's the restriction on it? Yeah, so 9 minus x squared has to be what? Greater than or equal to 0. Remember that radicals have to be positive or 0. Now what if it's a radical in the denominator? Just greater than 0, right? Solve this. If I subtract 9, I have negative x squared greater than or equal to negative 9. Wouldn't I divide by a negative? So x squared less than or equal to 9. Then what do? Take the square root and plus or minus the square root. And I have x is less than or equal to positive or negative 3. Now remember, your critical values are negative 3 and positive 3. So if this were on a number line, right? You would want to test that number line. I want to test in between. What's a great number to test in between? 0. So 9 minus 0 squared, what would that be? What's 0 squared? 0. What's 9 minus 0? 9. What's the square root of 9? 3. So I guess we'll have to plug it up here. So that's doable, isn't it? Right? And so this is true. What about if I chose 10 out here? What's 10 squared? 100. What's 9 minus 100 going to give me? A negative number. Can I take the square root of a negative? So it's false out here at 10. Then I like to choose negative 10. What's negative 10 squared? 100. 9 minus 100 is still a negative value. So isn't this false out here? So my answer is from here to here. Do you see why their domain includes negative 3 and positive 3 and everything in between? Okay. So that's why they put the restrictions on those. So now, f of g. You're going to plug in the square root of 9 minus x squared wherever you see an x. So find f of g. Rewrite your f function. And I'm going to put in the square root of 9 minus x squared. What happens when you square a radical? The radical goes away, right? So we end up with 9 minus x squared minus 9. The 9's cancel out. And I get equals negative x squared. So f of g of x equals negative x squared. That's not so bad, right? What's the domain of that function? Even though I put a restricted function in there, what's the domain of this? Is it restricted? No. So what's your domain? Negative infinity to positive infinity. You don't have to have the braces if you don't want to. So the domain of the composite function turned out to be not restricted at all. Perfect. All right, that's it.